All right, hello everyone. Let's talk about something we've all been through, the job search. What if we stopped treating it like a chore and started treating it like what it is for us, an engineering problem? Today, we're going to dive deep into ACOC, a project that does exactly that by building a robust, autonomous architecture to manage your career.
So let's kick things off by defining the problem space. We all know it, we've all felt it. The endless, frustrating, and just plain inefficient search for the right job.
I mean, it's a fair question, isn't it? With all the incredible technology at our fingertips, why is this process still so manual, so painful? Well, it really boils down to two things: a massive cognitive load on us, the candidate, and just an overwhelming amount of noise. We spend countless hours sifting through jobs that are, from an engineering perspective, a fundamentally bad fit. And here's the root cause of that noise. Most job platforms are stuck in the past. They rely on simple keyword matching, what we'd call syntactic search. You search for Python and you get every single job that happens to contain that word. A junior dev profile gets absolutely flooded with listings for a principal architect that require 15 years of experience. It's useless. Semantic analysis, on the other hand, understands intent. It gets that 15 years of experience is a deal breaker for someone with 1 year. That's the gap we're engineering to close. So, how do we solve this? Well, not with another simple scraper or a weekend script. No, we need a complete cognitive architecture designed from the ground up to tackle this problem. And that is the entire idea behind the Autonomous Career Ops Center, or ACOC for short. ACOC is an autonomous multi-agent system. Now, the best way to think about it is as a specialized team of AI agents all working in concert. Their mission? To manage the entire job application lifecycle for you, from the initial discovery of a role all the way to securely persisting the final application package. The core architectural thesis here is simple, but I think really powerful. We're combining two key things. First, a semantic matching engine. That's the brains powered by LLMs. And second, a classic battle-tested software design pattern called the Mediator, which acts as the project manager. And this pattern is absolutely crucial. It allows our AI agents to collaborate without being tightly coupled, keeping the whole system clean, scalable, and easy to maintain. So how does this actually work in practice? Let's pull back the curtain and meet the team. Let's see these specialized agents in action. First up, you have the Scout. Its role is that of an elite headhunter. It is the system's eyes and ears on the market. It's autonomously querying for new postings and, most importantly, performing that first critical pass of noise filtering. It brings back the raw intelligence for the team to work on. Next, that raw data gets passed to the Analyst. You can think of this agent as a seasoned senior tech recruiter. This is where the real thinking happens. It performs a deep semantic gap analysis, comparing the candidate's profile against the job's requirements to generate a concrete compatibility score. This is the core reasoning engine of the entire system. Now, if the analyst gives a high score, say anything over 80%, it triggers our creative specialist, the copywriter. This agent doesn't just fill out a template. It crafts a hyper-personalized, strategic cover letter based on the specific analysis done by the analyst. This is a key efficiency feature. We don't waste expensive creative cycles on low-probability targets. And finally, once an application package is fully drafted and ready to go, it's handed over to the secretary. Think of this agent as the chief of staff, completely obsessed with reliability. Its job is to ensure the final package is saved to a database in a fully ACID-compliant transaction. That's atomic, consistent, isolated, durable. Put simply, we never, ever lose data. So this gives us the full pipeline, all orchestrated beautifully by that mediator pattern. The Scout acquires the data, the analyst reasons about it, the copywriter executes creatively, and the secretary persists it securely. Each agent does its one job perfectly and then passes the baton. It's a clean, decoupled, and highly efficient workflow. So let's look at a real example from the execution logs to make this concrete. Our candidate profile here has 1 year of experience. The analyst correctly identifies the junior Python dev role as a 95% match and immediately engages the copywriter. But for the principal architect role, it assigns a dismal score of 15% and just filters it out. This right here is semantic reasoning in action. It saves everyone time by understanding the mismatch is just too big to even consider. So the concept is powerful. But look, we're all engineers. We know ideas are cheap. What makes the system truly robust isn't just the AI concept. It's the engineering discipline it's built on. So let's look at that foundation. The entire system is built on clean architecture principles. We have a very strict separation of concerns. The core business rules in the domain layer know absolutely nothing about the database. The application layer holds our agent logic, and the infrastructure layer handles all the messy external stuff. This makes the system incredibly testable, scalable, and a heck of a lot easier to maintain.
Now, in any AI system, especially one using LLMs, data integrity is paramount. You can't afford to have your agents hallucinating bad data structures. To prevent this, we use Pydantic v2 to enforce strict data contracts. Every single entity, from the candidate profile to the application package, has a rigid schema, guaranteeing that the data flowing through our pipeline is always valid and predictable.
And the crucial point I want to drive home is this. It's not just code, it's architecture. Beyond the mediator, we're using the repository pattern to abstract our database, a factory to centralize agent creation, and adapters so we can easily mock external services for reliable unit testing. Every single pattern was chosen for a specific strategic advantage to make the system better.
Okay, so this architectural proof of concept is solid, but it's really just the beginning. Let's talk about the roadmap to take ACOC from a personal project to a real product.
The next steps are pretty clear. First, we migrate this whole thing to a proper microservices architecture using Fast API and Docker to get it ready for real-time deployment. Then, we build a simple user-facing dashboard with something like Streamlit. And finally, we replace our mock adapters with live connectors to platforms like LinkedIn and Gmail to fully automate the entire process from end to end.
You know, this whole project was born from one simple idea: that we can apply the same rigorous engineering principles we use every day at work to our own career development. So the final question I have for you is, are you ready to engineer your career?
If you want to dive into the nuts and bolts, the full source code, the architecture diagrams, all of it is available on GitHub. I really encourage you to check it out, fork the project, and maybe even contribute. Thanks for your time.